Hey everyone, this is lesson 17, derivatives of inverse trig functions, and these are the inverse trig derivative rules. All right, so we know that we have 6 trig functions, and let's start with the inverse sine, okay? So we know that that starts with s, right? And I can see that there is a subtraction in the denominator, but I also see a square root. Now, take a look at the secant inverse down here, right? I also see a square root and I also see subtraction. So one of the things that we can help us to memorize these inverse trig function derivatives is maybe whenever you see that s, and I'm only going to focus on these first 3 here on the left for now, but when I see that s, I want you to think maybe subtraction and also square roots in the denominator there, okay? All right, something else that could help us is whenever we write the word sine, that almost looks like a 1, doesn't it? And so something else to help us distinguish from the inverse sine and the inverse secant is the inverse sine derivative will start with 1 in the denominator, whereas the inverse secant does not start with 1, okay? All right, something else that I can help me to memorize these is that when I write tangent, that looks like a plus sign, doesn't it? And so tangent, I'm thinking plus, all right? Okay, so that's what we see in the denominator there. Inverse tangent is plus. All right, so everything though says u squared. So usually when we see this inverse sign of like x, for example, well, the numerator would just be 1 over, and then we'll see the square root of 1 minus x squared. But if there's ever something in here that isn't x, maybe 3x squared and whatnot, then we'll have to do an application of chain rule. And that's why you see me just write u prime, right? Because times the derivative of the inside. So I just went ahead and put that in there. So u prime in the numerator, over, and then square root of 1 minus u squared, or of course we saw down here it could be u squared minus 1, and then it could also be 1 plus u squared, but basically they're all kind of similar, all right? That's all the shortcuts I have for you, or all the tips I have to memorize. The bad news is you do have to memorize them. Remember, all 6 trig functions show up on the AP exam one way or another, okay? What else do I have? Let's see. Let's talk about cofunctions. Cofunctions of, or the cofunction, better said, of sine is cosine. And so whenever I see inverse cosine and I have to do its derivative, well, I'm really just going to use this inverse sine derivative. I'm just going to throw a negative in the front. Remember that your 3c is always negative, right? And the cofunction of tangent is cotangent. So whenever I see the inverse cotangent, I'm using the tangent formula with the plus, but I'm going to put a negative in the front. And whenever I see cosecant, that's the cofunction for secant. So I'm using the the inverse secant formula here, but I'm just going to throw a negative in the front. All right. Now, one of the things I didn't talk about was this absolute value of u. We'll talk about that in a second. For now, just go ahead and write it down. Make sure that you pause the video and jot down these 6 derivative inverse trig function rules. Okay, so let's now talk about something that students confuse pretty often. We have the reciprocal versus the inverse notation. So whenever I see something like this, reciprocal, remember that this just really means I don't want a negative exponent, and so I can write it as 1 over x to the first power, okay? In other words, 1 over x. Now, whenever I see f to the power of negative 1, that's very different. This just means the inverse of the f function, okay? So very different, very different notations there, and we got to be careful with that, okay? All right, let's do some examples so that you can see how the inverse trig derivatives work. All right, so we'll start with the first one, inverse sine of x cubed. I know that the left side is y prime of this equation, and so the right side. Okay, well, I know that s has subtraction and square roots in the denominator, so let me make sure to start with that. So subtraction and square root, and this looks like a 1, so I'm going to go ahead and start with 1. Okay, all right, let me fill in everything else. In the numerator, that's u prime. This right here is u. So we're going to put 3x squared over 1 minus in the square root u squared. Well, what is x cubed squared basically? And that's just going to give us x to the power of 6, okay? Now I do want to delete this because that wasn't really part of my question. But this is my derivative right here, okay? All right, let's work with inverse tangent. So t is like plus, right? So I'm going to go ahead and write y prime equals, this is going to be u prime, so that's just going to be 5 in the numerator, over 1 plus u squared. Well, what is 5x squared? That's right, 25x squared. And this is my derivative. Okay, so now let's take a look at some secant questions. I have 2 of them because I want to talk about that absolute value, and I think it's worth doing a couple of examples with the secant, okay? So let's start with 3a. Y equals inverse secant of 5x to the power of 6. So when I derive this, I'm going to get y prime equals 2, and well, I know that s means subtraction and also square root, so let me not forget about that. And in the numerator, I'll put my u prime. Well, that's going to be 30x to the power of 5. Okay, now we said subtraction square root, but there's no one looking thing here. So this is going to start with u squared. Okay, anyway, 5 squared is 25, right? And then x to the 6 squared should be x to the power of 12. And then from there, let's see, minus the 1, right? Now, the only thing I'm missing here in my formula is the absolute value in the denominator of the u, which is just 5x to the power of 6. Now, here's the thing. We could reduce this down a little bit. We could simplify this, right? We could reduce that 30 over 5, right, to get that 6 and so forth. But we can also reduce those x's. You see, we got 5 x's up here, 6 x's down here. And so the catch is we got to decide if we're going to leave an absolute value in our answer or not. And this is probably the hardest part of the question. So what we want to do here is let's plug in -1. Let's plug in -1 for x into the raw version, like the unsimplified version, and see what we get, okay, sign-wise. So if I were to plug in -1 up here, -1 to the power of 5 would give me a negative value, right? Now, if I were to plug in -1 into the denominator, right, okay, let's positive, then this -1 to the power of 6 is positive. I get a positive down here, okay, which means that this derivative should be a negative value when I plug in -1, okay? Now, if I'm simplifying this, I want to make sure that I simplify it, but still get a negative value. So, okay, how do we simplify? Let's see. Well, we just reduced 30 over 5. That's going to give us 6 on the top, right? Okay, we can reduce this x to the power of 5, right? And there's more than 5 x's down here, so we can get rid of that. So now there's only 1 x left. And that's going to basically tell us, hey, we have x to the power of 1, but we just got to decide, do we want it in the absolute value or do we want it like this without the absolute value? And that's, again, the hardest part of the question, in my opinion. Okay, all right, so let's decide. Do we want it like this or do we want to throw that absolute value in there at the end? Okay, let's go back and plug in -1, just like we did before. If we plug in -1, the numerator is positive. But if we plug in -1 in the denominator right now, right, positive and negative, this right here is going to be negative. Hey, don't we get a negative value just like that? We do, right? And so that means that we want the answer without an absolute value. Okay, so this is going to be my final answer, simplified already, for that derivative. Okay, let's try it again, but this time we'll try it with the question on the bottom, 3b. Okay, derivative of the left side there is y prime. Okay, and the derivative of the right side, let's see. This is when we use that inverse secant formula. So u prime on the top, that's just 6, over the absolute value of 6x. And remember, secant is subtraction and square root. So we're going to put 6x squared. Well, that's just going to be 36x squared minus the 1. All right, so now that we have this, we're simplifying the 6's here. And, oh, I almost forgot. Let's plug in -1 to figure out that unsimplified sign, okay? Because when I simplify, I want to make sure to get the same sign. So let's see. If I plug in, by the way, there's only 1 left up here. When I plug in -1 for x, the numerator is positive. And when I plug in -1 for x, it's positive and positive, that's going to be positive again. right? So I need a positive answer, okay? So when I go to simplify this, we said there's 1 on the top, no more 6's on the bottom. We just got an x here, and we're going to decide put an absolute value or don't put an absolute value. All right, let's see. If I don't put an absolute value and I plug in -1 right now, doesn't that mean that I get a positive on the top and a negative on the bottom? That's not the same. This gives me a negative derivative answer, you see? And so I would need to put a absolute value there. And if I put an absolute value, then I get positive over a positive, and that's what I need, you see? So we got to be very careful to make sure that we understand answer has absolute value or doesn't, okay? I expect this to be an MCQ. You can expect one of the answer choices to have an absolute value and one of them to not, okay? All right, let's do an inverse cosine question, which is going to be, let's see, that's y prime equals 2. Ooh, it's one of the 3 C's, which means it's going to be negative, right? And also, so negative u prime, and then we have basically negative 20 x to the power of 4 over, and then now we're using the cofunction of the sign, right, which is square root. It is subtraction, and then the cofunction of the sign means we are starting with 1. So we're going to do 1 minus u squared, which means, let's see, 4 squared is 16. X to the 5th squared should be x to the power of 10. All right. Okay, so this is how we can write our final answer for that derivative. Okay. All right, let's keep going here. Let's look at number 5, another C, which means we have another negative, right? So that's going to be negative u prime on the top. So that's negative 18x squared over, and cotangent is the reciprocal of tangent. So that's plus on the bottom, all right? And I'm going to put 1 plus u squared. So 6 squared is 36. And then x cubed squared is x to the power of 6. Alrighty? Okay, so that's my derivative here, and we can leave our answer like that. All right? Okay, last thing that I want to go through is finding the antiderivative, right? And that just means the derivative in reverse, backwards. So if we have this, can we find the original function? All right? So yeah, we can, right? So I see the square root on the bottom. I see the minus. That's either secant or sine. And also, I notice that this starts with a 1, which tells me this is, whoops, sorry about that. This tells me that this is the inverse sine. So I'm going to write here inverse sine of something. Now, in order to find out what this is, my u, if you will, I'm going to take the square root of this because this is u squared. So if I take the square root of 36x to the 4th, don't we just get 6x squared? And that's going to be this value right here. Now, here's the catch. This is supposed to be the original function. Well, if I were to add like 8 to this, remember, we're staring at the derivative. That's how we find the original function. If I were to add 8 to this, and I asked you, let's derive this, we know that the derivative of this inverse sine is this guy here. But what's the derivative of 8? Isn't that just going to be 0? So there could have very well been an 8 at the end of that, right? Or what if I were to ask you to do, I don't know, let's go with like -2. Isn't the derivative of -2 also 0? Right? Or what if I were to ask you to do +2? Isn't the derivative of 2 also 0? And so that means that we could basically always have a constant at the end of this function. So whenever we take an antiderivative, we're just going to put +c because there may be a constant there. Now, if there isn't there a constant, it's going to be 0, but still put +c, all right? Okay, and then you might remember this formula for derivative of an inverse function. Just because I'm talking about inverses today, this is the formula. This is the formula from lesson number 13 that we talked about, okay? In this particular case, we talked about f and g being inverses, okay? And remember that this is just an application of chain rule. If f and g are inverses, it's because f of g of x is equals to x, but also because g of f of x is equals to x. right? So if you were to derive both sides of this equation right here, let's do that real quickly. We end up with a chain rule of the left side, that's derivative of the outside, copying the inside times the derivative of the inside. And that equals to what? Derivative of x is just 1. And now to isolate g prime, I could just divide to both sides this thing right here to cancel that out. And that's how I'll get this f prime of g of x, okay? And so that is how we obtain this formula, which you saw right here. So even if you forget this formula, the derivative of an inverse function, you can always use that chain rule application, take the derivative of both sides, and then you find that formula to use to find the derivative of the inverse, okay? All right, I hope that that was helpful. That wraps up lesson 17. And the next one would be lesson 18, L'Hopital's rule.